Now, we will discuss how to visualize the data. Before I continue with charts and graph, so let me tell you once again that till now we have discussed what are different level of measurement, and if we broadly classify what are different types of data. So once data is there, it is very difficult to understand what exactly the meaning, what exactly this data present to you. So for better presentation, visualization helps a lot. So now we will discuss different types of charts and graph. So before I start with chart and graph, let me tell you what exactly we will be doing in this case. We will see how to construct frequency distribution for grouped data, or if it is ungrouped data, so then how to group it first. Then we will see how to summarize data graphically in case when it is qualitative data, and similarly how to summarize the data when it is in quantitative way. Finally, we would like to see if there are two different variables, then how to summarize that graphically and what exactly the meaning we can infer from there. Now suppose we have collected some data lying with us as it is. For example, 10 observations are there. I have listed out all the 10 observations. I have not done anything, just mention that all 10 observations are there. So that is your raw data. Whatever you have collected, so as it is, you have written somewhere or listed somewhere. Then if you arrange that data in some way, that if some kind of similar observations are grouped into one category, it may be some characteristic. For example, if suppose data is related to age, I can make some category as per the age, for example 20 to 30, 30 to 40 and so on. Or even if I am having suppose some data about the gender, so I can put them in some category, maybe under male how many observations are there and under female how many observations. It could be location, it could be any kind of, or quantitative as well. So now, for example, we have the data related to ages of a sample of manager from Urban Child Care Center in United States. So now in this data, you can look at the screen. This 42 is actually the age of some person. Then we have next person. We have collected some information. We have asked that about that particular person's age. So we found that it is 26. Then next one is suppose 32 and so on. So now it is very difficult to get an idea that what is happening. How to convert this raw data, this is ungrouped raw data, into some meaningful information. So is there any way to do that? Now see, we will convert this data into frequency distribution. We will actually summarize this data into intervals and frequencies, and there will be different shapes and design, and it depends that what is the requirement of a researcher, what is the nature of job, what exactly we are expecting from that data. So shape and design will depend upon that. Now when we create frequency distribution, there are certain steps. First of all, you need to determine the range of frequency distribution. So range is nothing but you have to just identify what is the minimum observation and what is the maximum observation in this. So difference of that largest and smallest value is nothing but your range. Then you need to calculate number of classes. Now we need to keep in mind that classes should not be too many so that it is difficult to handle, and also not too few so that the purpose for which we are converting data into some classes, that is not served. Again, we have maximum number of observation in one class, and even after classification it looked like that again we need to classify that particular class into some subclasses. So then we need to find out what could be the appropriate width of the class so that data can be converted into appropriate frequency distribution. Now for that purpose, mathematically what we do, although we are not using very difficult mathematics, simple mathematics, plus, minus, division, multiplication, this kind of simple. So we would like to fit all the value in some of the category, but there should not be any kind of overlapping. Now what would be the width of class? So simply, first you decide that how many classes do you want from this particular data. So then range can be divided by that number and you will get approximate idea of the class. So if suppose number comes out to be in fraction, so you need not to worry about that. So nearest number, make it in a round figure. For example, in the same data which we are discussing, we have made some classes 20 to 30, 30 to 40 and so on. And then we identified that how many observations are there in each of the class. So for example, in first class we have 6 observations and second class we have 18 and so on. So now what happened? How the data is distributed among these interval, or you can say in each category what is the frequency of the data, how many observations are there in each category. So how the data distributed, how these frequencies are distributed among each category is nothing but your frequency distribution. Now next term which we might be using somewhere in some kind of analysis, so that is your relative frequency. So how do we calculate relative frequency? Just take a sum of all the observation. All the observation means all the frequencies of each class. So like here 6 to 1, the 20 to 30, then last class is 70 to 80. If we take a sum of all the classes, we will find total number of frequency is equal to 50. So divide each frequency of any of the class. If you divide it by total, for example, for first class we have frequency 6. So total number of observation 50. So 6 divided by 50 comes out to be 0.12. What does it mean? Out of total data, 12%, around 12% data is there in this first category. Similarly, we can calculate the relative frequency for all the classes. Then we have cumulative. So cumulative is nothing but a running total. So what we will be doing? You keep on adding next observation in the last one, and at the end you will find the last class cumulative frequency is nothing but the total number of observation in your data. What is the running total? Then again similar, the way we calculated relative frequency, we can also calculate cumulative relative frequency. So in cumulative relative frequency, again Keep on adding the relative frequency of next class and you will get the next number. And again the total. Last relative frequency would be the total of all the relative frequencies, right? So in this way we can have cumulative relative frequency. So it can be calculated directly making the running total of these frequencies, or if you convert first into cumulative frequency, so again you can calculate. Simple calculations are being used. It would be easy to understand, and I hope you are getting all these kind of calculation here. Now when we talk about statistical graph, particularly for quantitative data, we have certain types of graph. Most of the time you will be using this graph for quantitative data. For example, histogram. It looks like a bar chart, vertical bar chart of the frequencies. We will see that what does it mean. Then we have frequency polygon, the line graph of frequency. Then we have ogive, the line graph of cumulative frequency, and then it comes stem leaf plot and Pareto chart, and we will see one by one what exactly and how do we construct these chart. So for example, this historical is a graphical summary of frequency distribution. I hope you still remember we had converted raw data into frequency distribution table. So this is histogram is nothing but the graphical representation of frequency distribution. So what we do, the number and location of bins bar should be determined based on the sample size and the range of the data. Once that is known, for example, in this data range is 51, largest value and smallest value, range is 51, class width you divide. So as I told you, you need not to worry about the fractional number. So nearest round figure number, to make it easy, you can go for that. For example, class width in this case we might consider, and the rule, the fewer than 5 classes cause excessive summarization and more than 15 classes have too much detail. So this we need to keep in mind while we are making histogram, or even in case of frequency distribution also. Then accordingly, because in some of the case we also require class midpoint. So what are class midpoint? In any interval, whatever is the beginning point and ending point, add them and divide them by 2, we will get class midpoint, right? There is alternate calculation also. Okay. You can see same example, how to convert your frequency distribution table where all the frequencies are given. So those frequencies into midpoint, those classes into the midpoint, and then finally use those classes as a bin, and whatever is the number of observation in each class, that would be the height of this rectangle. Whatever is the frequency of that class, that would be the height. Width also matter, because width is nothing but the size of class. So now once you have made this particular histogram, so what does it mean? This histogram tells us what is the distribution of data, how data is distributed. If you see here, you can easily find out that if you start from the in first two category, no observation, But once you start, so there is peak in the third category, then continuously or gradually it is going low. So means in between around 30 to 40 or 40 to 50, there are maximum number of observations in this particular case. If I join the midpoint, if I join the midpoint of the classes, then you will find this type of curve, this type of line graph, which is nothing but a frequency polygon. Similarly, you can plot the cumulative frequencies, so that is known as ogive. Cumulative frequency against each class interval, if we plot them, for example 20 to 30, we have certain value there, then similarly it goes up to 24, because in 20 to 30 it reaches up to 6, then 30 to 40 it reaches up to 24, and 40 to 50 reaches there at 35, and so on. So this is graph of actually running total, so that is known as ogive. Similarly, relative frequency ogive can be constructed. Now we have stem and leaf plot. For example, we have some data related to safety examination scores for plant training. Now this is also a kind of frequency distribution, but have you observed one thing here? In frequency distribution, whenever you are clubbing the data into some category, you know the number of observation, but you are not having any idea about that exactly what observation is that. So here one advantage is, when you convert the data into some category, it can also show you each value, what exactly that information is there in that particular category. For example, if we have data in 2 digit, so first digit can be considered as stem. So we will see that how many category can be made. So here if we start from 2 to 9, so these are some categories, and second digit will be considered as leaf, or you can say this will represent the number of observation in this particular category. For example, we have one observation 23, so 2 in stem and 3 in leaf. Similarly, next observation was 39, so 3 in stem and 9 in leaf. So now this particular stem and leaf plot also showing some kind of distribution of the data, and you are also aware about exactly that observation. So this is the way we have created this stem and leaf. Now when we talk about histogram versus stem and leaf, so histogram is what? Histogram is actually graphical representation of frequency distribution. So when we compare these two, so which one should I use? A stem and leaf is useful for small data set. It shows the value of the data points, and histogram foregoes saying the individual value of the data for the bigger picture of distribution of the data. The purpose of this graph is to summarize a set of data. As long as that need is met, either one is okay to use. So in nutshell, we can get this idea that if data is very large, so it would be difficult to handle it through stem and leaf. We will have to take help of histogram. Now we have common statistical graph which we use for qualitative data, and most of the time when you will be doing some statistical analysis, you will find that pie chart, bar chart. So pie chart means proportional representation for category of a pool, and bar chart is just frequency or relative frequency of one more categorical variable. For example, we have data related to the complaint by Amtrak passenger. So this is one of the local train, or you can say the metro kind of thing in US. We have different types of complaint. So complaints are related to stations, complaints are related to train performance, equipment, personnel, schedules, and we are given the number of observation in each of the category, and we have found the total, and now we know that how to calculate that relative frequency is nothing but the proportion out of total, how much is this particular part. So now you just see in a circle we have 360 degree, in a circle we have 360 degree. So now you can see that 40% if I have to represent in a circle, so how many degree it require. You need not to make this manually, so we will be using MS Excel for this purpose, but right now just you try to understand. So this 40% means these many degree of that particular circle, and similarly you will see that for 21% these are the number of degrees which we can mention, and total 360 degree. So means total 360 degree of circle are divided into different category in this way, and you will find this type of chart. So that means when you have to divide total into some component, or you want to see for each category what is the importance, what is the weight of that category, so we will use pie chart. And for the same data, suppose there is another data set which is related to second quarter US truck production. So there are certain companies which produces these number of trucks, right? So now I want to present this data. So again the similar way I can use pie chart, convert the data into relative frequency and see that how much proportion of each particular frequency is there. So accordingly, so there we have mentioned that how to find out that proportion means each category, whatever the number of observation is given, against that divide that number by the total number of observation, and you will get that relative frequency, and accordingly multiply this proportion with the 360, you will get the degrees which require in that particular circle. So now we have Pareto chart. Suppose in some situation, in any company, particularly manufacturing company, they are facing some problems. So now they want to know which particular types of problems are happening more in number. So if I have to take some corrective measure and I want to maximize my output, I want to do things correct in a speedy manner. So I need to understand what are those problems which are actually responsible, or what are those types of problems which are responsible for maximum thing, right? Or what are those, for example, here we have poor wiring, short in coil, defective plug and other. So what are those categories which are responsible for maximum damage? So if I take care of that particular part first, so it will provide sometime optimization of resources, sometime you want fast corrective measure, so it can resolve most of the problem, because Pareto analysis says that 80% of the problems may be due to 20% of the reason. So if you identify those reasons which are accountable for most of the problem, so it would be easy to understand, and you can also parallelly know that if you have suppose sorted out two issues, so how much actually out of total you have solved the problem. So this Pareto chart will help you in solving those kind of problem. So now we have another very important statistical graph which is known as scatter plot. The type of display using Cartesian coordinate you must have studied in your school level. What are those Cartesian coordinate? So now we will just try to understand what exactly we do with the scatter plot. For example, we have two variables. So how to present those two variables into some scatter plot? So the data is displayed as a collection of points, each having the value of one variable determining the position on the horizontal axis and value of other variable determining the position on the vertical axis. And when we will plot, we will find some dots against x-axis and y-axis, and those are nothing but scatter diagram. So how it will be appearing? So you just see. For example, we have data related to registered vehicle and sales of gasoline. So I want to see what kind of relationship is there between these two variables. So in this case, scatter plot can help me. So what I will be doing, on x-axis I have entered the registered vehicle and y-axis gasoline sales. So when I plot, so I found these type of dots. Now what does it mean? If these dots are forming almost a straight line, not exactly straight line, but almost a straight line, so we can interpret there is some linear relationship. So in this case, you can see if I put some line diagonally from starting from 0 0 and this, we will find that most of the points are close to the line, right? So next thing is, if most of the points are near to each other, points are very near to each other, so that means there is strong association between or strong correlation between these two variables. If these points are scattered far from each other, that means there is weak association, weak correlation. And when one variable is increasing, for example, with the increase in number of registered vehicle, we can see there is increase in gasoline sales. So that means movement of both the variable are there in one direction. So this shows that there is positive association. If case is vice versa, so then suppose one variable is increasing, other variable is decreasing, and graph you will find diagonally in opposite direction, coming from higher top to this bottom. So that would be negative association when the variables are moving in opposite direction. So whether there is linear relationship or not, whether correlation is strong or weak, whether it is positive or negative, so that can be understood by using scatter plot. So with this, we have actually discussed most of the relevant graphs which normally we will be using in the statistical analysis. I hope you must have understood all of these. Thank you.